And good morning and welcome to Mini Geology. But first, some meditation.
I said I will have satisfaction. I will be satisfied. I said I will be satisfied when I'm believing satisfaction, when I'm grieving satisfaction, when I'm singing satisfaction, when I'm praying satisfaction, when I'm staying satisfaction, when I'm carousing, when I'm 1,000, I'll sit it out, we'll have satisfaction, I will be satisfied before I'm gone, before I'm gone, I will have satisfaction, I will be satisfied, I will have satisfaction, I will be satisfied. Now Mr. Jagger and Mr. Richards, I will scratch where I've been itching. Now Mr. Jagger and Mr. Richards, I will scratch where I've been itching before I'm gone, before I'm gone, before I'm gone, before I'm gone.
I'll be satisfied before I go. Geology? Mini Geology. This is Daniel Minizini, your inquisitive geologist from Italy and Spain and from Houston, marathoner and terrible husband. And today we have in here a couple of guests. We are going to talk about the important role of geology in society. We are going to talk with Patricio about the poetry in geology, and we'll have a special guest. In the previous 2 episodes of the Mini Geology show, we interacted with a representative of the geological community in Houston, which was the president of the Houston Geological Society. And then in the following show, we talked with the representative of the petroleum geologists in the world, the president of the American Association of Petroleum Geologists. Well, today we'll have a representative of academia expressing another point of view, and this is the head of Earth Science Department at Rice University, Cin-Ty Lee. So call us, call to ask him questions, and to forge together this program, Mini Geology. And this is the telephone number, so take your pen and write down this telephone so that you can call 713-526-5738. It is up to you and to your feedback if the show will be kept. So call, and we're going to take your call at the end of the program or during the interviews. And the telephone to call again is 713-526-5738. Or if you are one of those shy people, you can write me to minigeology@gmail.com, or you tweet or your Facebook. I don't know if you can use Facebook as a verb. You Facebook and you tweet at Mini Geology. So, why? Why a program about geology in Houston? Well, the city, this is Houston City, and this is the city with most geologists in the world, probably. 10,000 geologists. So Houston for geologists is like Rome for priests, Hollywood for actors, or Paris for poets, Washington for politicians. That is what is Houston for geologists. And we have this program also because geology affects our daily lives. And I'm going to tell you, like for instance, how does geology affect our daily lives? Well, geology brings you most of those materials that they surround you right now. They're brought by this discipline, geology. So plastic comes from oil. Glass comes from silica. The bricks, they are just clay, like ceramic, or asphalt. If you are driving your car right now, all the roads. Steel is nothing else than a metal ore. So let me introduce now to this funny mineral, graphite. Graphite is a mineral that you can find in metamorphic and igneous rocks. They are made of atoms of carbon. And in 2004, two scientists, they had the art to peel a single layer just one atom thick. And this one layer of atoms of carbon, this is called graphene. And you know what? Now, graphene will make your cell phones and your tablets so flexible that you'll be able to roll them up like your shirt sleeves. And now I want you to listen to this piece that is talking about graphene.
From the Bureau of Economic Geology, this is Earth Date. Graphite, the shiny gray stuff in your pencil, has unexpected powers. When you write with it, you're scraping off a very thin layer. For decades, scientists tried to slice a layer just one atom thick, which they called graphene. But it was only 13 years ago at the University of Manchester that they succeeded. Graphene turned out to be far more miraculous than they could have ever imagined. It's the thinnest compound known to man, thousands of times thinner than the human hair. It's also the lightest, 1,000 times less dense than paper. Graphene is harder than diamonds and 200 times stronger than the strongest steel. Its ability to conduct heat is 1,000 times greater than copper. It's also the best-known conductor of electricity at room temperature. It's impermeable to gases. Not even helium can pass through it, while being transparent, highly flexible, even stretchable. And get this, if it does get torn, it can repair itself. Not surprisingly, this incredible material will transform our lives in the future. It will lead to lighter, faster, more efficient, and much smaller electronics, lighter, stronger aircraft, new industrial products like impermeable paint, consumer products like better tennis rackets, and because graphene is carbon-based, just as we are, the biotech possibilities are too many to mention. Meanwhile, I'm placing bets on a new comic book hero, Graphene Man. You heard it here first on Earth Date. I'm Scott Tinker.
Earth Date is produced by the Bureau of Economic Geology at the University of Texas at Austin. Earth Date is researched by Julie Hennings, written by Harry Lynch, and distributed by Mark Blunt and Casey Walker. For more stories, follow us on Facebook or visit earthdate.org.
Thank you, team at the Bureau of Economic Geology, to share this with us, Mini Geology at KPFT Houston 90.1. So, that was just one example of how geology affects our lives, but there are many others. And one day I'll tell you about tourism, how the geologists, they know why you go and you do tourism in the beaches of Florida or in the Caribbean islands. In geology, it affects also history. Once I'll tell you how Napoleon lost his battles because of an explosive volcano that exploded a couple of years before Waterloo. And then we have literature, where many elements in the literature that are related to geology, as well as poetry. So all of the above is part of this poetry that exists in what we do. Poetry in its etymological meaning, so that comes from the Greek poiesis, which means to create, to invent, or imagine. So I've here a good friend, Pato, that he's going to talk about the poetry that we have in geology. Welcome, Pato.
Hello, Daniel, and thank you for inviting me to share with you and the Mini Geology audience, fragments of a poetic book of geology, written by the group of kids and young adults from the community of Amaicha del Valle, Tucumán, Argentina.
So you're going to talk about a book that was written in Argentina?
Yes, we're going to talk about a book written in Argentina, with basically this book, what expresses is the voices of the participants of these workshops that we did in Argentina, teaching geology. Let me start by saying something special about this community, is that they have a link to Earth through their ancestral beliefs. So, they have a lot of respect for Earth and what they call Pachamama. Basically, maybe not the right translation, but, a way to explain this is Mother Earth.
Now, we have so many songs about the Pachamama that we should know what is Pachamama right now.
So so what we did to teach geology in this community, and let me just stop there and tell you why we were teaching geology. We were teaching geology to help this community promote geotourism. So how we can, in some way, generate, more interest of visitors on this place. We can, let's show them the rocks. So
you were one of the teachers in Argentina?
Yeah, I was one of the teachers teaching this community about geology, so they can later guide tourists through their beautiful outcrops. So they have, this, but the way we try to communicate geology or teach geology was to relate to something that they are familiar with, and that was Pachamama. So basically the geology class became a class of the anatomy of Mother Earth. And that's how we put it, and that's how we were able to connect. So it's very important when we are teaching geology, to be able to connect with the audience. And we found that this was something familiar, and we can introduce into concepts in a way that they can actually relate to.
So this is because these people, they were continuously living in the same place, and were they indigenous?
Yes, it is. And it's actually I think one of the few communities in Argentina that they still have the rights to their land. Okay, so that's something. So let me start with the introduction of the book, okay? And I will read you fragments of the book so you kind of see what I'm talking about, and how these people, or these children that now, they may be adults by now.
So how old were the students when
they were between, I would say, 6 and 16.
Oh, right. Okay.
So we have a good mix.
And so almost they didn't know anything about geology.
No, they didn't know. So let me just first read you the introduction that will maybe set the scene of what we're trying to do.
Yeah, tell me again, what's the title of that book?
Journey to the Depth of Time.
Oh, right. Okay, go ahead.
If you could see the Earth as a changing organism and not as an inert body, see in each fold of its surface as a wrinkle of a body that grows, and think its rivers as veins, we would not just be on a planet, but spinning on the physical body of Pachamama. If we could feel this way, galloping the Earth, one of the objectives of this book will be accomplished. But it's not simple. To understand this perspective, we must first transform our perception of time and learn to read in the rocks the process that gave them birth. At any given point on Earth has a story that can be reconstructed. It's much simpler and easier if we have many rocks to look at. So one of the biggest challenges that we have when we're teaching geology at the beginning is the concept of geologic time or deep time. Actually, we introduced that and put that in the title.
And I see that is one of the concepts that is discriminatory, because you can understand if one is a geologist because he has the concept of deep time.
Yeah. For us was, how we can, in order to create this mental picture of Earth moving, Earth changing, we really need to change that perspective of time. So
how do you do it?
So let me just read you how.
How do you inoculate the deep time into 6-year-old kid?
So let me just read you what they wrote about deep time. So using their voice.
Let's see. Voices. This is Voices. KPFT Houston, and we're going to listen now to the voices of the kids in the indigenous population of Argentina, that they are learning about geology from Patricio here with us.
Around 10 a.m. in the library that is just in front of the main square by the church, we started our geology class without really knowing where it was going to take us. What is a lot of time? Asked Pato the geologist. 1 year is a lot of time for Maria, the youngest of our class. For Tonina, an adult with a young soul, is around 100 years. But what is a lot of time for you, Pachamama? This is a question that sounds in the interior of all of us that got together this early morning of November to write a book about geology. Gilda and Melina noticed that learning about Earth, planeta containers, that invites us to wonder its body, letting us know about its constant changes, is like making a journey through time. Using our imagination as a vessel, says Gilda, is possible to enter a story of a journey. Pachamama will have the main role, but we know that she lives in a deep time, in which seconds are thousands and hours are millions. So basically what the first thing we do was just fast forward what you see. Just think about 1,000 years is 1 minute of your time.
That's interesting. I tell you, sometimes when I do that with the kids, I say, think about years like money. So they know what is 1 million.
Yeah.
So 1 year is $1. 1 million years is $1 million. So things they're put in perspective for the youngsters. They know about it. That's very interesting.
So the second one, the concept that we introduced to them, is plate tectonics. And probably is one of the most popular geology concepts, and we can actually probably explain or link back to plate tectonics almost everything that happens on the Earth. So, how these kids...
How do you do it?
How did they explain it?
Oh, how did they? Okay, so it means that you already taught them, and then what is the feedback that you get from them?
So, we taught them about the plate, the rock is fragmented, they move. So, what is this for you? What do you think? What analogy can you find? And this is what they wrote.
Okay.
Tectonic dancing plates. Mabel and Marcela tell about this part. The rest of the members collaborate with sparks of poetry, which eventually blaze the rest of the journey. Lithospheric plates dance at the beats of the Earth's heart, move independently one from another, but always influencing the dance of the other. When two meet, the heavier will continue at its own pulse underneath the lighter one. The dance speed increases, the temperature too, more and more. It sinks, it melts. It's not what it was, it changed. Now it's magma. The magma will eventually continue changing and becomes rock if it is necessary for equilibrium. Also, the collision of two dancing plates produces wrinkles in the landscape, which rise towards the sky, making our soil shake. These wrinkles are our mountains. Wrinkles? How old is Pachamama?
I see. We are so proud to have you here and to talk about the voices of geology. We're here in Houston talking about kids 6 to 16 years old in Argentina talking about Pachamama. This is Voices. This is mini geology. This is what we do. We give you voice, and we try to engage you with these topics about geology.
Okay. Thank you, Daniel, and thank you for letting me share their voices.
You're very welcome, Pato. So let me say something now about Geo Minds, which is very well related with what Patricio said. Like, when geologists, they analyze natural aspects of the earth, like a river. In our brain, we see where the river is going to move in 1,000 years or 10,000 years. So then we say to engineers, and they build, they take care, and they take precautions, and they protect. So we geologists, we don't have a geomind to build stuff. We merely indicate. We point with our finger. We like to finger point. And we point where the problem will occur. We are cornucopia of ideas. We're kind of what the philosophers are for society. Like philosophers, they indicate the way. So the philosophers were the ones that they indicated democracy. They are the ones that indicated the dialogue and freedom, happiness. So then the others, they move towards those indications. So we know how difficult it is to acknowledge the role of philosophers, right? You don't want your kid to be the first choice to go and study philosophy. So the same happens with the role of geologists, a castigated role with little acknowledgement, no Nobel Prizes or Pulitzer Awards. In the past, there was more time to read geology and to debate about it. Now, the pace is different, faster, right? So we geologists, we don't fit in the short political cycles that are 4 or 8 years long, or maybe sometimes only 2. But like, for instance, engineers, they do. They fit that political cycle because they can certainly conclude a project, a road, a building, a tunnel in those 4 or 8 years. We don't have products to show. So, here we come. I would say this. If the mountain won't come to Muhammad, then Muhammad must go to the mountain. I aim to send to the Congress of all countries, the geologist. We need more Geo Minds. And it is not enough to advocate and lobby just to include geoscientists in the process of developing and implementing energy policy. I aim to bring geologists to the Congress. Even if we geologists, we have a tremendous vice. We like our discipline too much. We like to look at rocks too much. We like to solve our own little problems so much. And we don't give a damn about participating in the broader debate. It's too complicated, too many people that do not understand a thing, not to mention how we hate to be exposed to the public arena. But why should we do it, we say? This is a hustle, or I like to stay with my data and solve my problem. Being exposed doesn't help at all. On the contrary, I create buzz and enemies. This is the vice of the geologist. Well, I am convinced that if the congresses around the world would have more geologists sitting on those chairs, if we would have more of these Geo Minds, the world would spin around in a different and better way. I'm convinced about that, and I tell you why. I know it because geologists, they are used to analyze the complex natural systems. I'm going to tell you, obviously I need to support this idea, okay? So this is one of the points in here. Geologists, they're used to these complex systems. Like society, it is a complex system. Well, they're used to handle the natural system, which is as complex as if not more. And the intricacy of the interconnected components in here may result in unexpected feedbacks. So this means that geologists see a bigger picture. Just think about the complexities of our society: immigration, education, or the lack of education, geopolitics. Okay, and this is the second point now. I know it because I know that the geology would let the world spin in a different way, because the geologists, they approach problems that are plenty of uncertainty and with incomplete data. So therefore, the geologists, they excel in tackling these open-ended problems. And the open-ended problems are the ones that they may have several correct answers. So this means that they are trained to explain which solution would be better, or which solution would be more likely or more convenient for that moment. But above all, the geologists, they are tolerant. because they recognize that there are plenty of competing views on each specific topic. As the data they receive, they're always incomplete. So, complex natural systems, incomplete data, and now I give you a third reason. Fourth dimensions. Geologists, they have a brain that continuously analyzes in 4 dimensions. So obviously the typical 3 dimensions. When I say the 3 dimensions, I don't mean the space that we inhabit, but also the space that is underground, the subsurface, and the space that is in the sky, the atmosphere. So geologists are very used to this, and they analyze those 3 dimensions while the time is changing. So, and I connecting here with what Patricio said, the geologists, they handle the 3 dimensions with this 4th dimension, time, and not the typical concept of time, days, years, even centuries, but deep times, millennia or millions of years. So to handle 4 dimensions, it means that the geologists are juggling with complex problems, analyzing them not only in the present, but also in the past and in the future. So they foresee long-term problems and benefits as well. So this helps anticipating new problems and therefore giving to society more time to reflect on those problems. I see it like the geologists are kind of juggling while they are running, but the point is that they do it professionally. That is what they do day by day. They juggle while they're running, and they do it very well. These are 3 good reasons. And then one personal, I think that the geologists, they are generous. I know several colleagues and friends that they donate, and they donate their time, like some of us are doing here. They donate their money, like some of you already did to sustain this radio. They donate their knowledge and their experience. So I love this community. Wasn't it clear? And I recognize that not all geologists are equal. Okay, so although not all geologists are equal, and although also geologists would be trapped in the short-term political cycles, I am convinced that they would perform better in Congress and leaving a deeper track of their pondered decisions. I'll say more. I aim to have a geologist our president, geologist for president. And to do that, we do need to come out. So you passionate geologists, you that you are listening there, that you already know how to lead a project, or you are already into an institution and you are a leader of that institution, you have ties with the public institutions because you lobby there. Come out and act. These are times where we need to act. This could be dark times and we need to act. So you come out. Ora et labora. Dicebat our saint. Ora et labora. Da Norcia. Yeah. So pray, but you also act. And the first act to do, I think, is to reform our public education. That is what we think. I think that we need to reintroduce a strong program of earth science in K-12. Let's start from there. I give you this hint. Let's start from somewhere. Texas Board of Education, they moved away of earth sciences in 8th grade in the 90s. And they inserted physics and chemistry, which we also love, but we're talking about the Geo Minds in here. So you need earth science. K-12, they need geology. And we need to require courses or a course in high school. I I think that this will create a cascading positive effect, because the reintroduction of earth sciences, it means that good teachers of earth science will be willing to work in high school, while now they are not. And if better teachers of earth science, they go to high school, they will not only create great geologists, technical, good geologists, but, this is the most important thing, they will forge a new civil behavior in the new students, which will be the new citizens. So all of the above, all the things that I said before, so respect society, be tolerant, respect Earth, and then a new way to understand the complexity of the systems, the lack of data, a new way to integrate disciplines, and a new way to have the 4 dimensions in your brain. So this would create the new Geo Minds. This will create the feedback, that positive cascading effect, to get at a point where we will have a geologist for president. So I think that we need more Geo Minds. And talking about president, I have here on my left a very honorable host and guest in here. He's not a president yet. Technically it's not, but he's a chair, which is very funny because you are a chair. It's like you're an object, but you are a chair. Welcome to the chair of the Department of Earth Science at Rice University, Cin-Ty Lee. Good morning, Cin-Ty.
Good morning. Thank you, Daniel, for inviting me. This is great. I'm really excited that you're doing this. The vision you have, I sort of feel like we're almost brothers. All the things that were just you said are exactly how I think that Earth science is about. It's a way of thought of bringing everything together, seeing the world as a complex system.
It's a way of thought. That is the synonymous of the Geo Minds that I was talking about.
That's right. And almost looking like Patricia was saying, as the body as an interconnected system. The Earth is all interconnected. Anything we do has consequences. We want to exploit the Earth to support our economies, but we also have to deal with the consequences. So,
Cin-Ty, tell me something. So, if you think like I was expressing myself, what is that is moving you? What is moving internally to do the work you do and to be passionate and be in that position on the chair?
Well, I would say there's 2 parts to that. One is chair, and one is just why am I interested in geology. And at its fundamental level, as a geologist, I'm a petrologist. I look at rocks. I like to be out in the field, be out in nature, and get to see basically how the plants, the birds, the soils, the rocks, the lands, the mountains, how they're all interconnected. And you get out there and you see that the world, your backyard, is something really special to understand how things formed and how they behave. So that's what drives me scientifically. And interesting that you mentioned this in the beginning, that many of us earth scientists or geologists, for a long time, we just like to keep our head to the ground, study our rocks, work on our mass specs, make maps, never want to be involved in the bigger picture there. But being thrusted into this position of chair, suddenly realized that there's a lot more responsibility I have beyond just myself, beyond even our department, but to the community, to sort of educate everyone out there in this mindset.
So that means also that you had, because you had this possibility, and because of your merits, and you arrived to that position, then you became more aware of the role of geology. But what about all of the other geologists that they don't have the luck or the merit to arrive to your position? How do we teach them to think in this broader way?
Well, I think geologists all are already thinking this way. And not everyone has to be doing outreach or being in a leadership position, but everyone has their role. We're doing research, understanding how natural resources form, how to extract them more efficiently and more environmentally consciously, and then how to take care of the environment after you've exploited the resources. So, everyone has their role in that sense.
Cin-Ty, tell us something about Rice University and the Department of Geology. Where is the department going? A department that, by the way, is not called Department of Geology, but Department of Earth and Environmental and Planetary Science.
Yeah, we changed our name, and the reason why we did that, so it used to be Earth Science, and then we add on the Environmental Sciences now, and it's sort of a statement here in Houston, the energy capital of the world. And many of our students go into the energy industry, meaning hydrocarbons. Some go into the mining industry. But we also are very interested in doing environmental studies. And having a name is sort of a brand, too. It pretty much says, look, we're serious. This is where we're going to go in the next 10, 20 years. The space science, too, is important there. So planetary, we want to kind of recapture Rice's and Houston's legacy in space exploration, planetary exploration.
So Rice, in a way, is expanding in environmental sciences. And by this you mean which kind of environmental sciences, like natural hazards and natural resources?
Oh, it's a lot of things. Natural hazards is one. I think one of our big goals is to deal with coastal sustainability, and that brings in a lot of factors, like what is the effect of rising sea level on our coasts, $1 billion industries down there, both medical and energy and chemical refineries. How do we deal with rising sea levels or more hurricanes, more storms? Whether you think there's more, it doesn't really matter. There's just a lot more people living on the coast, and so we have to deal with that. And so as earth scientists, what we do is look at the past time and use what we learned from the past to make better predictions about the future. And that's the big thing that is really not missing, or the biggest challenge is, and where earth scientists really have to come in to do it, is making predictions for the future, so we can actually plan or develop strategic plans to respond to environmental change. There are other aspects of the environment that are not necessarily our department, but Rice in general. There are, of course, social aspects that have to be dealt with too. So it's not just our department. Many other departments at Rice are kind of collectively interested in the environmental science and studies and policy at the moment.
We are talking with Cin-Ty Lee, the chair of the Department of Geology. I'll abbreviate that. Officially is Earth, Environmental and Planetary Sciences. And we are here talking with him at Mini Geology, KPFT 90.1 in Houston. And let me ask you something, just as a curiosity.
Yeah.
Okay, because some people, why Rice University is so expensive? And
well, that's probably above my pay grade to explain why it's so expensive. It is, it's private schools tend to be more expensive, but I will say that although we're expensive, we are cheaper than Harvard.
For sure, yeah. And let me ask you, so what are the kinds of students that you are looking for your department?
So, well, what we are interested in and what Rice excels at is we just have a lot of the creative students, and students that tend to be weird, and I mean that in a good sense. They have many other talents. They have a broad picture of the world. You'll have students that are interested in music, but at the same time interested in science and so forth. So we're always interested in students like that. And in our departments, we get we really like students that when they come in, they're really good at the math and the physics, but they have a real passion for nature, for looking at the rocks, looking at the landscapes. Those are the type of students that we most enjoy.
And what about the faculty staff?
Our faculty, I feel very grateful to be able to be part of this department. We got 18 faculty, and what's remarkable about our department is that we all work together. all of us have our core discipline, but the way we've hired, especially in recent times, is to find people that are just fundamentally creative and that are able to adapt with the changing environment. If the fields change, they change. And when you get people who are just creative, rather than say, I'm going to hire this person because he or she just does this to fill expertise, by hiring for creativity, you really build a different type of team, a culture, and then we adapt with changes in the field.
And now talking about the department, the departments of geology around the country, do they tend to collaborate or they tend to compete against each other?
Between departments?
Yes, of different universities.
I don't know if it's anything like that. Of course, in the world of science, just like in the world of business, we're all competing. And if you don't compete well, you will die. But at the same time, we have this fraternity of that we're all geologists. We all love the same thing, so we do work together. And there's so many examples in our departments where we collaborate with other people in other universities. We have one of the colleagues, Raj Dasgupta, just put in the proposal for a NASA Astrobiology Institute, and that brings in people from UC Davis, UCLA, NASA JSC, and ourselves. And so we got plenty of projects that also international. So.
I see that. So it's kind of a collaboration in a competitive environment.
Yes.
And we talked about this last week. We call it co-opetition. Co-opetition is a collaboration in a competitive environment, which is what the departments of geology are doing in the country, right?
Yeah, and geology is, if you want to study the Earth, it's such a big field. You need someone to understand how the mountains are built, or how the climate influences the building of the mountains, how the oceans influence the climate, and then people have to understand how biology interacts with the Earth and vice versa. And no department has all of them, but when you look around all the institutes around the world, there's people out there, and we have to come together.
Let me know now, in your position, is there a particular goal at the top of your priorities that you would like to achieve? Do you have a moonshot?
Yeah, well, we do have a moonshot, and we may never reach it, but we are already starting. And the biggest thing, we want to put together an institute at Rice called the Institute of the Earth, Environment, and Energy. Energy is important here, and we want to be a place where we can talk in a balanced way about renewable and non-renewable energy and all the environmental consequences that go with it, including for the renewable energies. They are not perfectly clean. For example, batteries, lithium cobalt batteries, you got to have lithium and cobalt coming from somewhere, and that involves strip mining in some places. So, and also an immense carbon footprint. So we really want to tackle some of the key challenges to our society right now. The ones that I think we have strengths in at Rice in the city of Houston are natural resources. That includes hydrocarbon, but also water, that soils for agriculture, fertilizers like phosphorus. If you don't have that, you can't feed 7 billion people on this planet. And of course, all the metals and rare earth elements that go into our...
Like graphene that we just talked
graphene,
about.
Yeah, and the rare earth elements in my Prius. These are big deal things we have to worry about. And this other one is this coastal sustainability. We have strength in that, and Houston is ground zero for any coastal changes in the coastal environment. With the growing population, Houston's going to be the third largest city in the country soon, and if we can't solve it here, we're going to have problems in this country. So I think our department, Rice in general, has to take some sort of leadership role in at least pushing us in that direction. And then finally, just what you were talking about is education. And now more than ever, I feel that that's a mission of our department. This is education of the mindsets of earth sciences across all ages, all demographics, starting with K through 12. We're in the works trying to figure out the best way to do that. We may start a K through 12 teaching certificate program for geosciences. And then continuing education for people who are, say, been in the workforce and they come back when they're in their 30s or 40s to learn a little bit more about how our planet works.
And talking about education, this is also communication.
Yeah.
We have a role as communicators in order to educate. So what would you like to say to the public that we have out there right now? And you have like two kinds of public. We have the scientific community that is listening to us, and then on the other side we have a mother, a worker, a grandpa, or a student that is listening to us. What are the messages that you want to convey through the radio waves now?
Well, I think the most important thing is to think about the analogy, perhaps, to think about your planet as your backyard. And we have to be stewards of our backyards. We're going to grow our vegetables in our backyards, for example. We're going to generate waste. And if your backyard is limited, you may not be able to feed yourself all the time. You have to get rid of your waste somewhere. And you may throw it in your neighbor's yard, but eventually we're all one big family, and you can't just throw it everywhere. So this goes back to this whole interconnected system that we're all in it together. And learning a little bit about the Earth and the environment helps us understand these linkages. And at the other level, it helps you just enjoy being on this planet. You go out to Enchanted Rock, you'll feel, well, I know how this thing formed, or it's 1 billion years old. Just simple curiosities like that.
We talk about the geology and the environment, but we didn't touch on the planetary science. Is there anything that Rice wants?
Yeah, planetary is another thing. I didn't mention that so much in interest of time, but yeah, we see. I mean, some people think we got to go into planetary exploration because they're people in Silicon Valley.
Planetary exploration.
Planetary exploration. Right?
What do you mean by that?
Well, going to other planets, not necessarily sending humans there, but going there, sending missions there to understand how they form, how their climate or the habitability of that planetary body has changed with time. And you might ask, well, why do we really care about that? And of course, we care because of our fundamental curiosity. But the other reason why we might care is it actually helps put perspective back on our own planet. And if we learn something about Mars or the Moon, maybe we'll better understand our place on Earth, in the solar system.
And what would be the role of the Department of Geology at Rice for this planetary exploration?
So our role would be to kind of train a new generation of students to really see the Earth as a whole system from the very beginning of how it formed, and going to where we are now, where we have life. But Earth is just a planet, and we would be talking about the formation of Mars and the Moon, the Mercury, and so forth. We are very excited. We just hired a young assistant professor named Kirsten Seebach, who actually works on Mars missions. So she will actually arrive here in January, and what she does is actually she navigates these Mars rovers. They're running around Mars and they're making observations, geochemical observations, photography, everything. It's amazing stuff. Much of this technology is, in fact, the same sort of technology that's used in the oil industry when they're doing logs down in their cores, and there's remote sensing. So it's that hybrid of interests, but using similar skill sets that we like to emphasize here at Rice. So with her coming, we'll be looking at Mars, but we'll also be looking at the deep recesses of the Earth with the same techniques.
So you don't say that, but it seems that you want to lead a mission to another planet.
I don't. I don't have the credibility to lead it, but I hope some of our younger faculty will, and I think they are on the way to doing that. And my role is really to support them and to help them get to where they want to go.
And so tell us again, what is that your department does for the Society of Houston? What does the Department of Geology exactly do to help Houston in the surrounding areas?
Well, we're building up that outreach at the moment. There are a couple of things. The first thing is we have this started actually with the previous chair, Richard Gordon, Industry Rice Earth Science Symposium, and it's now coming in on its 5th year. And what that is supposed to do is we are trying to become like the catalyst to bring people in energy, people in the medical center. We have the largest medical center in the country, people in the space industry, and the academics all together, creative minds to tackle problems of similar interest. And so far, in our 5th year is going really well. And so that's bridging all the industry communities. And as for outreach to everyone else, we've started a magazine with very much the same goals that you have for starting this radio station, which is it's called Outcroppings. The second one will be out in a couple weeks, and we hope that is sort of more like a written voice of Houston, of Texas, in terms of earth, energy, and environment. And one of the goals there is to explain the love of science, the passion of what we're doing, but also explain in lay terms things that most people might think are too technical, but we could explain, well, how did enchanted rock form in a way that a 10-year-old...
Where do we find the magazine? Is online?
It's online right now.
On paper?
It's on paper. We're still trying to figure out. We're in the early stages trying to figure out how to distribute this everywhere. But we'll probably print 400.
So what about the listeners that are interested in the magazine? How can they reach it?
Go to our website at earthscience.rice.edu, and then click on Outcroppings. You'll find that.
And Cin-Ty, tell us, what do you want to do when you grow up?
Oh. Well, that's a funny question. I think as I've grown up, I found the thing that makes me happiest, the mission really, is about helping others achieve their goals. And if I can do that, then I'll be happy.
I'm so glad. That is the Geo Mind. That is the generosity I was talking about. Thank you so much, Cin-Ty Lee, the chair of the Department of Geology at Rice University in Houston. And we are here wrapping up right now. And to wrap up, I would like to reiterate what I said before and what Patricio and Cin-Ty, they emphasize as well. I am convinced that with this kind of Geo Minds, the congresses around the world, they would make the Earth spin in a different way and in a better way. So geologists, they are generous. As I said, I know several colleagues that they are donating their time and their knowledge, why not their money, especially for this station, KPFT 90.1. We are all volunteers in here, more than 200 volunteers, only 4 people, they are staffed, and we need you to stay on the air and to give voices to our communities. We geologists, we are part of the many communities of that puzzle that is Houston. We are a little tiny part. We are a mini part. This is why we call it mini geology. And I remember one about, among the many, my dear colleague at the prison show, Linda. She's a geologist, and that is probably what attracted me to come and volunteer here at KPFT, that a geologist was working with the prison show. And by the way, here we have Hank of the prison show also around in here. So talking about the prison show, so it is true, in life there are other topics that they are more important than geology. That's true. I volunteer for the prison show, and there are things that are way more important than that. But I want to say that geologists, they know how to tackle those important topics, and they know how to solve those complicated problems because of their Geo Minds. I think that we need more Geo Minds. That is what I think. Thank you so much, listeners. Thank you to Patrick helping on the other side of the glass, and thank you to our General Manager, OBDK. Thank you so much, Mini Geology. See you next time.